Hello everyone, this video is for week 7, topics 5 and 6, part 1, and our topic is graphing exponential functions. This topic can be found on pages 105 to 111 of your modules, and we will be discussing examples 1 to 4. So for our lesson outline, we have reflection, vertical stretching and shrinking, and we have vertical and horizontal shifts. So let us start discussing example number 1. Use the graph of y is equal to 2 raised to x to sketch the graphs of the function y is equal to negative 2 raised to x and y is equal to 2 raised to negative x. Okay, so let us start sketching the graph of the function y is equal to 2 raised to x. Okay, so this is the graph of the function y is equal to 2 raised to x. So how about if we sketch the graph of y is equal to negative 2 raised to x? So we have y is equal to negative 2 raised to x. Okay, so this is the graph of the function y is equal to negative 2 raised to x, and we have this is the graph of our function y is equal to 2 raised to x. So what can you say about these two graphs? What can you say about the graph of this function y is equal to negative 2 raised to x in relation to the given graph y is equal to 2 raised to x? Okay, so any observation? Okay, how about if we will be comparing this graph y is equal to 2 raised to x to the next function, the graph of the next function y is equal to 2 raised to negative x. Okay, so this is the graph of y is equal to 2 raised to negative x. Okay, what can you say about the graph of these two functions? Okay, any observation? So for example number 1, we will be comparing the graphs of the functions y is equal to 2 raised to x and y is equal to negative 2 raised to x. And we have another pair. We will be comparing the graph of the function y is equal to 2 raised to x, and we have y is equal to 2 raised to negative x. Okay, so before we proceed, let us start from the first pair of the functions. So I would like to emphasize that for the first pair of our functions, we have positive 2 and negative 2 as our bases. Okay, so these are the graphs. And for the second pair of the functions, okay, so we have the same base 2, and our exponents we have positive x and negative x, and these are the graphs. Okay, so let us discuss more about this. Okay, for the first pair of our function, okay, so for the first pair we have the graph of y is equal to negative f of x is the reflection about the x-axis of the graph of y is equal to f of x. So take a look at these two pairs, the graph of this first pair of functions. We have positive 2 and negative 2. So this graph is just the reflection of the given is the reflection of the graph of the given function y is equal to 2 raised to x about the x-axis Okay, so your x-axis is just the axis of symmetry. So they are just the reflection of each other about the x-axis. Okay, so that is the first pair of the functions. Let us proceed to the second pair of the functions. So we have the graph of y is equal to f of negative x is the reflection about the y-axis of the graph of y is equal to f of x. Okay, so this time we have the same bases. We have 2 and we have positive x and negative x. So their graphs are just reflection to each other about the y-axis. So this is your y-axis, and this is what we call the axis of symmetry. Okay, so let us have more examples. If we have the function y is equal to 3 raised to x, so this is the graph. If I will be asking you to have a function which is symmetrical to y-axis, what would be our function in relation to the function y is equal to 3 raised to x? Again, we have symmetrical to y-axis. What do you think is the function? Okay, so we can have y is equal to, we have 3 raised to negative x. Okay, so we have this. How about if I would ask you if give an exponential equation or function which is symmetrical to y is equal to 3 raised to x, but they are symmetrical to x-axis. What would be the function? Okay, so we can have y is equal to negative 3 raised to x. Okay, so we have these graphs. Okay, so again, for example number 1, we were talking about reflection. So reflection about the x-axis and reflection about the y-axis. So that's for example number 1. So we have example number 2, used to graph of y is equal to 2 raised to x to graph the functions y is equal to 3 times 2 raised to x and y is equal to 0.4 times 2 raised to x. So let us start with the function y is equal to 2 raised to x, and this is the graph. And we have also the function y is equal to 3 times 2 raised to x, and this is the graph. Next, we have also the function y is equal to 0.4 times 2 raised to x. Okay, so we have these 3 graphs. So what can you say about these 2 graphs? And we have also what can you say about these 2 graphs? Okay, so for example number 2, from the given function y is equal to 2 raised to x, your 2 raised to x was multiplied by 3 and also multiplied by 0.4. So what happens to the graph? Okay, so let us proceed. Let us have some observations. The domain of these 3 graphs is a set of real numbers. So for this, we have for all the values of x, we have the corresponding values of y, or for all the values of y, we have also the corresponding values of x, such that these values of x are elements of real numbers. So it means to say that you can assign any values of x as long as these x are elements of real numbers. Okay, so there is no restriction. Okay, so next we have the y-intercepts were also multiplied correspondingly. the y-intercept of y is equal to 3 times 2 raised to x is 3, and the y-intercept of y is equal to 0.4 times 2 raised to x is 0.4. So this time we are talking of y-intercept. Okay, so for this graph y is equal to 3 times 2 raised to x. Okay, so this graph intersects your y-axis at point 0, 3. For this graph intersects your y-axis at point 0, 1, and this graph intersects your y-axis at 0, 0.4. Okay, so again, for this graph the y-intercept is 3. Again, if you can still remember, the definition of y-intercept is this is the value of your y when your x is 0. So it means to say that when your graph intersects your y-axis, immediately the values of your x becomes 0, and therefore the value of your y is what we call the x-intercept. Okay, so for this graph, the values of your y is the y-intercept. Okay, so for this graph, the y-intercept is 1, and for this graph, the y-intercept is 0.4. Next, the three graphs have the same horizontal asymptote, which is y is equal to 0. So the horizontal asymptote is y is equal to 0. And this is the horizontal asymptote, or your x-axis. Okay? Okay, so this is the line that the three graphs would approach, but these three graphs would never intersect to this line. So that is your horizontal asymptote. And we have also the range of all three graphs is the set of y such that y is greater than 0. Okay, so if you can see, our three graphs are found on quadrants 1 and 2, where the y coordinates of the points found in quadrant 2 and quadrant 1 are all positive or greater than 0. Okay, so such that your range will be, it's a set of y such that y is greater than 0. Next. Okay, so for this example number 2, let a greater than b greater than 0 be a constant. Okay, so the graph of y is equal to a times f of x can be obtained by multiplying the y coordinate of each point of the graph of y is equal to f of x by a. The effect is vertical stretching if a is greater than 1, or vertical shrinking if a is between 0 and 1 of the graph of y is equal to f of x. Okay, so in this case, we have, if we will be multiplying 2 raised to x by 3, so from this graph it stretches vertically, so it becomes, this is now your new graph, so it stretches vertically, while if you will be multiplying 2 raised to x by 0.4, it stretches, or it shrinks vertically. Okay, so in this case, we have two values of x, which can be found on the two intervals. If your a is greater than 1, or if your a is between 0 and 1. Okay, so let us have some examples. So if we have y is equal to 3 raised to x, So this is the graph. How about if we want to have the y-intercept, which is 4? So what would be our function? Okay, so 4 is greater than 1. So the effect is vertical stretching. So from y is equal to 3 raised to x, we will be multiplying. We have 4 times 3 raised to x. Okay, so in this case, we have our y-intercept equal to 4. So how about if we have 0.25 as the value of your y-intercept? So of course, this will become y is equal to 0.25 times 3 raised to x. So we can have 0.4, we can have 0.1, and we can have 0.25. So we have the y-intercepts 4, 1, and 0.25. So for example number 2, we were talking about vertical stretching. If your a is greater than 1, and we have vertical shrinking if your a is between 0 and 1. So that's all for example number 2. Next, we have example number 3. Use the graph of y is equal to 2 raised to x to graph the functions y is equal to 2 raised to x minus 3 and y is equal to 2 raised to x plus 1. So let us start with the function y is equal to 2 raised to x, and this is the graph. Now let's sketch the graph of the function y is equal to 2 raised to x minus 3. Okay, so this is the graph of that function. And we have also the function y is equal to 2 raised to x plus 1. Okay, so we have these three graphs. Okay, so what would happen to your graph y is equal to 2 raised to x if we add 3, if we subtract 3 to 2 raised to x? So this would be the graph. What would happen to your graph? Okay, and what would happen to the graph of y is equal to 2 raised to x if we will be adding 1 to 2 raised to x? Okay, so for example number 2, we are just adding or subtracting a number from 2 raised to x. So let us have some of our observations. The first one is the domain for all the three graphs is a set of real numbers. So we have, for any values of y, there corresponds the value of real number x. Okay, so it means to say that you can assign any real number to x, so there is no restriction. Okay, second, the range of y is equal to 2 raised to x plus 1 is a set of y such that y is equal or greater than 1, and the range of y is equal to 2 raised to x minus 3 is a set of y such that y is greater than negative 3. So let us go back to our graph. So let us start with the second function, y is equal to 2 raised to x minus 3. So if you can see, as the value of x decreases, the value of y approaches negative 3. Okay, it approaches the value of y equal to negative 3, and this graph approaches to the line y is equal to negative 3. Okay, so it approaches but will never intersect to the line y is equal to negative 3. Okay, such that the value of y must be greater than negative 3. So there is no value of y less than 3 or equal to negative 3. 3. Okay, that is the range of this function. How about this function? Y is equal to 2 raised to x plus 1. Okay, so as you can see, as the value of x decreases, the value of y approaches to positive 1. And this graph approaches to the line y is equal to positive 1. Okay, so it approaches to the line y is equal to 1 but will never intersect. So it means to say that the value of your y is always greater than positive 1. It could not be equal to 1 or less than positive 1. Okay? Okay, so let us proceed to the next. The y-intercepts on horizontal asymptotes were also vertically translated from the y-intercept and horizontal asymptotes of y is equal to 2 raised to x. So let us start with these two graphs. Okay, so this is the graph of y is equal to 2 raised to x, and this is the graph of y is equal to 2 raised to x minus 3. So it says, let us start with the y-intercept. So this graph intersects your y-axis at point 0, 1, and this graph intersects your y-axis at point 0, negative, 0, negative 2. So it says our graph is just vertically translated. It could be upward or downward. So in this case, we have minus 3. So from positive 1, your y-intercept is vertically translated downward 3 units. So it became negative 2. From positive 1, it would be this time negative 2. So vertically translated downward. Okay, same is true with the horizontal asymptote. So the horizontal asymptote of this function is y is equal to 0. Okay, so this is the horizontal asymptote, and the horizontal asymptote of this line is y is equal to negative 3. Okay, so it is also vertically translated 3 units downward. Okay, so we have minus 3 units downward. So we have 1, 2, 3. Okay, so how about if we have the next function? Okay, so this function, so we have y is equal to 2 raised to x plus 1. So we have plus 1. It means to say it would be vertically translated upward 1 unit. So for this, the y-intercept of this is 0, 1, and this the y-intercept of this is 1. This one, the y-intercept is 2. So the intersection of the graph and the y-intercept, the y-axis is 0, 2. Okay, so when we add 1, so it is vertically translated 1 unit upward. Okay, so what happens to the horizontal asymptote? So the horizontal asymptote of this is y is equal to 0, and this one, the horizontal asymptote of this is y is equal to positive 1. So still from here, from the horizontal asymptote of y is equal to 2 raised to x, it is vertically translated upward 1 unit. Okay, so this is the vertical asymptote of the function y is equal to 2 raised to x plus 1. Okay, next we will proceed. The horizontal asymptote of y is equal to 2 raised to x is y is equal to 0. We have discussed that earlier. Shift this 1 unit up to get the horizontal asymptote of y is equal to 2 raised to x plus 1, which is y is equal to 1, and 3 units down to get the horizontal asymptote of y is equal to 2 raised to x minus 3, which is y is equal to 3. So we have already discussed that earlier. Okay, so we are talking of the horizontal asymptote. We have y is equal to 1, y is equal to 0, and y is equal to negative 3. Okay, so it's just shifting upward or downward. Okay, so let us continue. So for example number 3, let d be a real number. The graph of y is equal to f of x plus d is a vertical shift of d units up if d is greater than 0, or if d is positive, or a vertical shift of d units downward if d is less than 0 or negative, of the graph of y is equal to f of x. So it means to say that it depends on the value of d whether you shift your graph upward or downward. Okay, so if your d is positive, you shift your graph d units upward, and if your d is negative, you shift your graph d units downward. Same is true with the y-intercept and the horizontal asymptote. So let us have additional examples for cases in example number 3. So let us start with y is equal to 3 raised to x. Okay, so this is the graph. I would like to have a function which is translated 3 units downward. Okay, so 3 units downward. So we have y is equal to 3 raised to x, and this is minus 3. So we have 3 units downward. So let us have from positive 1, 1, 2, 3. So we have 3 units downward. So the graph of y is equal to 3 raised to x is translated 3 units downward in our graph is y is equal to 3 raised to x minus 3. Okay, what if I would have a function whose y-intercept is at positive 3? So it must be that the intersection of this graph must be 0, positive 3. Okay, so what would be our function? So it could be y is equal to 3 raised to x. So our target is to have our y-intercept equal to 3. So the function would be y is equal to 3 raised to x plus 2. Okay, next, what if I would like to have a y-intercept which is equal to, or I mean the horizontal asymptote which is y is equal to negative 2. So the next function must have a horizontal asymptote of y is equal to 2. What do you think is the function? Okay, So we have 1, 2, 3. So how many shifting below the graph of y is equal to 2 raised to x? Okay, so the horizontal asymptote, it could be our function would be y is equal to 3 raised to x, and then we have minus 2. Okay, so this is the function whose graph, whose y or whose horizontal asymptote is y is equal to negative 2. Okay, so that's all for example, more of the examples for cases in example number 3. Okay, so let us discuss example number 4. Use the graph of y is equal to 2 raised to x to graph the functions y is equal to 2 raised to x minus 2 and y is equal to 2 raised to x plus 4. Now let us start with the graph of y is equal to 2 raised to x, and this is the graph. Next, we will sketch the graph of the function y is equal to 2 raised to x minus 2. Okay, so this is the graph. Okay, and we have also the function y is equal to 2 raised to x plus 4. Okay, so we have now these 3 graphs. Okay, so I would like you to take a look at these 2 graphs. Okay, so your x is being subtracted by 2 for the first 2 pairs. Okay, so what happens to your graph from 2 raised to x to 2 raised to x minus 2? And then we have the second pair. Okay, so what happens to your graph from y is equal to 2 raised to x to y is equal to 2 raised to x plus 4? Okay, so for your example number 4, we have this time we are adding or subtracting a number to the exponent x. So what happens to the graph? Okay, so let us proceed to some of the observations. Okay, so the domain of all the 3 graphs is a set of real numbers. Okay, so we have still the same. You can assign any values of x or any real numbers to x. There is no restriction. Okay, such that the domain is a set of x such that x is an element of real number. Next, the range of all 3 functions is the set of y such that y is greater than 0. So for all the values of x, there corresponds the value of y such that y must be always positive. So if you can see, you can also only see the 3 graphs in quadrants 1 and 2, where the values of your y, the values of the y coordinates of the points which are found on quadrants 1 and 2 are always positive. So there is no 0 or negative values of y coordinates for the value of y. Okay, next, the y-intercepts change. Okay, to find them, substitute x is equal to 0 in the function. Thus the y-intercept of y is equal to 2 raised to x plus 4 is 2 raised to 4 is equal to 16, and the y-intercept of y is equal to 2 raised to x minus 2 is 2 raised to negative 2 or 0.25. Okay, so for this one, the y-intercept, we will be looking for the y-intercept. We will just make our x equal to 0 and solve for our y-intercept. So let us start with the first function. If you are looking for the y-intercept, we will let our x be equal to 0. So we have 2 raised to negative 2 is equal to 2 over 2 squared, or 1/4, or 0.25, such that for the y-intercept of this function, this graph intersects your y-axis at 0.25, or 1/4. Okay, so your y-intercept is 0.25 or 1/4. Okay, now if we have this graph, what is the y-intercept? So the y-intercept would be, we'll let this be equal to 0. Okay, so you have 2 raised to 4 is 16. So therefore, the graph of this would intersect at your y-intercept at 0, 16. 0, 16, and this graph would intersect at 0, 16. Okay, so this is 0, 16, and the y-intercept is 16. Okay, okay, next, translating a graph horizontally does not change the horizontal asymptote. Thus, the horizontal asymptote of all the 3 graphs is y is equal to 0. So in this case, our y-intercept, our horizontal asymptote is y is equal to 0, or the x-intercept. So these 3 graphs would approach the line y is equal to 0 but will never intersect, so such that our horizontal asymptote is y is equal to 0. Okay, so let us proceed. So for example number 4, let c be a real number. The graph of y is equal to f of x minus c is a horizontal shift of c units to the right if c is greater than 0 or positive, or a horizontal shift of c units to the left if c is less than 0 or negative of the graph of y is equal to f of x. So let us have an example. So from the graph, from the function y is equal to 2 raised to x, and if we have y is equal to 2 raised to x minus 2, our c is positive 2. Okay, so y positive. So we have here y is equal to f of x minus c. If our c is positive 2, so we have x minus positive 2 is x minus 2. Okay, so in this case, the value of c is positive 2, which is greater than 0. Okay, so in this case, we have horizontal shifts of c units to the right. Okay, so we have from here, our c is positive 2, we have 2 units to the right. We will be shifting our graph 2 units to the right, so it means to say from 1 we have 1, 2, so it means to say your graph will be passing through the point 2, 1. Okay, so the graph shifted 2 units to the right. Okay, because our c is positive 2. Okay, next, How about if we have c is less than 0, or if our c is negative? So in this case, we have this y is equal to 2 raised to x plus 4. Our c is negative 4, y negative 4, because from this we have f of c x minus c. If our x is negative 4, so x minus negative 4 will become x plus 4. Okay, so your c is negative 4, and what happens to your graph is if your c is negative, or less than 0, your graph is shifted 4 units to the left. Okay, so from this we will be moving 4 units to the left. 1, 2, 3, 4. Okay, so that is for example number 4. Okay, so for example number 4, we are shifting from left, it could be to the left or to the right. It depends on the value of c. Okay, so if your c is positive, you will be shifting your graph to the right. If your c is negative, you'll be shifting your graphs to the left. Okay, so let us have more examples for case number 4, which is the horizontal shifts. It could be left or right. Okay, so let us start with y is equal to 3 raised to x. Okay, so 3 raised to x, this is the graph. So what happens, what would be your graph if I would like to shift this graph to the right, which is 3 units to the right? Okay, so our graph would be y is equal to 3 raised to x. Okay, so if you will be moving to the right, your c must be positive. Okay, so minus c, so this will become minus 2 units to the right, we have 3. We have 3. Okay, I mean 2 units, we have 2. Okay, so we have 2 units, we have 1, 2. So 2 units to the right, and the value of our c is positive 2. Okay, next I would like to shift our graph y is equal to 3 raised to x to the left 3 units. Okay, 3 units, so we have y is equal to 3 raised to x plus 3. We have 3. So we have shifted our graph y is equal to 3 raised to x, 3 units to the left, and our function is y is equal to 3 raised to x plus 3. So we have 3 units to the left, 1, 2, 3. Okay, so for example number 4, we have discussed the horizontal shifts. It could be right or left depending on the value of c. So for this video, we have discussed graphing transformations of exponential functions starting from reflection. We have also discussed vertical stretching and shrinking. We have also the vertical shifts, and we have horizontal shifts. So I hope you have learned something out of this video. Thank you very much, and we will be seeing each other soon.